Hi guys, I hope you had a great conference so far and still have some brain capacity left to put more knowledge into your brains. And I'm Michael Staib. I'm a Microsoft MVP and I'm one of the authors of the HotChocolate GraphQL library for .NET. So let's get started with some GraphQL. So most .NET developers actually do not really know what GraphQL is. When I go to conferences or user groups, I often just see a few raised hands when I ask them, do you know GraphQL? Have you ever used it? And there's also a lot of confusion about what GraphQL is in the .NET community. Some people think it's a graph query database language, or some people think it's some kind of an OData just from Facebook. And that's far from it. So actually, Facebook started work on GraphQL in 2012, and they did that because back in the days they introduced a new set of mobile applications. Like everybody knows the Facebook app for their mobile devices, and back then Facebook earned a lot of criticism for their web applications. For their mobile applications. And that was due to the fact that the apps burned through the battery life of the mobile devices very quickly, and also had some other issues like startup times were slow and the app overall felt very sluggish. And on top of that, the application also burned quickly through the data plans. So they consumed a lot of data there. And Facebook built these initial apps actually with standard web technologies. So they used HTML for the visual parts, and they used REST in the backend. So after the criticism that Facebook earned, they looked into the problem, and they saw just when the application starts, it already fetches hundreds of connections to fetch data. So in order to understand what actually was the problem, I prepared a demo. I like to start with demos into talks because they make you understand much better what the actual problem is. So there is a site or a demo for REST APIs. It's called the Star Wars or the swappy.co, and it's a Star Wars API that basically depicts how you can build good REST APIs. And what I want to do here is I will try to solve a problem with the REST API, and then we're going to do and solve the same problem with GraphQL API. So first we use swappy.co, and the problem that we want to solve is basically we want to fetch all the Star Wars characters that appeared together with Luke Skywalker in Star Wars movies. It's an easy enough task. We just want to generate one set of names. So basically a set of the names of the characters that appear together with Luke Skywalker. And for .NET developers, or I think for backend developers in general, these REST APIs are easy to navigate and easy to understand. So in our swappy.co here, we have basically a site to explore like Swagger, and we can see it has a few endpoints here. REST is about is built around the concept of resources. Like we have a resource here that is called people that is exposed through the endpoint, through the people's endpoint. And we basically can navigate those data by drilling in, by fetching these endpoints. So I could fetch the people's endpoint, and I would get a list of characters basically. For instance, I get the Luke Skywalker character here. Or if I scroll down, I get the C3PO character or the R2D2 character. So basically, this is a list of my characters. And I can already see it has a lot of properties here, and I can see it has a URL property, and I could fetch a specific character. So I prepared that already. And when I do that, I basically get a single character. And again, I have all the properties that I had in the list. And I can see Luke Skywalker's name, and I can see we have a films array here, so I can kind of see what films Luke Skywalker played in. And the interesting part here is that the movies are represented by UIs. And the UIs are basically references to the films objects. And I basically can fetch them again and would get the films instance that I fetched. And again, I have a lot of properties here, like title. They don't interest me, actually. And I can see I have a characters array. The characters array is actually, again, a list of UIs. And each of these UIs points to a character that appeared in that movie. And I could go along that way and fetch all the movies, so I could kind of see how I could gather this data. So what I've done is I took a little bit of JavaScript. It's the only JavaScript you see today, so bear with me. I wrote a little JavaScript to basically implement our algorithm that basically first fetches our Luke object from the swappy.co, and then we iterate over the films array that we saw in our data structures. And then we fetch each of the films. And again, we would iterate over each of the characters and then fetch each of the characters and then push that to a characters array. Here we would do some data massaging to just extract the name. But just looking at the code, we already see that this might not be the most efficient way, but let's see how this performs when we run that. So I can go here into my my program that I wrote, and let me just get up the developer tools of Chrome and just run the REST version. And I already can see it's pulling up a lot of connections. I have quite a fast internet connection, but it still took 1.6 seconds. And I can already see why, because we actually created a data waterfall. So we have dependent calls that basically I first have to fetch Luke, and I can see the first call fetch the full Luke object. So I fetched all the data that I actually don't need. I don't need the Luke data. I just actually need the films that he played in. And then I fetched a lot of other data, like here I might have fetched a film, and we can dig in deeper and see, okay, here I've actually fetched a character that I need, and I actually just needed the name, but still we fetched the whole object. Okay, so let's explore how we would do that with GraphQL. So I have prepared here a GraphQL IDE that's also built by our project, and we basically have the same API built for GraphQL. And the interesting aspect here is that this GraphQL API actually uses the REST endpoint in the backend. Okay, so let's explore how GraphQL works. So let me just refetch my schema here. So this is my GraphQL server. It's hosted here. And I can see when I click here on the book icon that I have a query type. I will explain what a query type is in a minute. And I have some field that is called character here. And I can click on that and drill into basically my type structure of my GraphQL server. So the character field actually exposes to me a character object. And if I expand that, I can see the character field needs an ID and will give me a character back. And the character has attributes like in the REST API. But when we look at the movies array here, we can see instead of getting a reference for this object, I actually get the object back. And I can drill into that object and see that it exposes the characters like the REST API, and I can drill in. So before I did my first request against this API, I could fully inspect the type system of my GraphQL server. Okay, so let's have a look at how we would query a GraphQL server. So in GraphQL, we would start with a keyword query, because the query keyword indicates that we want to do a read request to our API. And then we would start like in JSON with some squiggles. And then already our IntelliSense kicks in, and we can choose what field we want to use. And I remember from my from the REST data that Luke Skywalker is actually ID 1. And I could kind of just say, okay, I want the character 1, and actually I want the name of the character. Okay, let's fetch that just. And boom, I just specified that I want the character 1, Luke Skywalker, and I want the name of it. And actually I got exactly that back in the same structure. And so in GraphQL, request and response closely align. So let's get back to our algorithm that we wanted to write. So actually, we don't want the name of Luke Skywalker. We actually wanted the movies, and we just want the movies because in the movies there are characters, and that are the characters that appeared alongside Luke Skywalker. And from these characters, I just want the name. And I'm basically done with my algorithm. I can fire that up, and I have my list of names. So in GraphQL, I basically can drill into data and describe data in a more structural way. And that basically helps me optimizing my requests, because I don't have to overfetch or underfetch, because I can specify what I actually need, and the server fulfills this need. Okay, so let's see how that would perform in our unscientific benchmark here. I wrote the same request now for GraphQL, and let's fire that up. And we can see 644 milliseconds. It's the half, but let me just see the data waterfall here. We can, damn it, let's do it again, because yeah, somehow my Chrome is messed up. I have here a prepared version, because actually the real fetch is much faster. Often Chrome enqueues the request, but the actual data fetching takes only milliseconds. Like in this case, it takes 42 milliseconds, and all the rest is basically often either a coarse request that is before the GraphQL request, and the actual data fetching is much, much faster. So 42 milliseconds and only 2.8 kilobytes against 1.6 seconds, and I think it was over 100 requests. Okay, let's get back to my slides. So with GraphQL, we are reversing the responsibilities. Like the consumer of the API is put in the driver's seat. The consumer of the API defines what data he or she needs at which specific time or in which specific component. And the server basically fulfills that need. And in GraphQL, query and response, or request and response, closely align. And that's one of the key features. In REST, we could also build something like that. In REST, we could also build dynamic APIs. We could have sparse fields. But if we look at, for instance, this dynamic endpoint from the Amazon Shop API, we can see that it's very difficult to read, and we cannot discern from the request how our structure or what comes back really will look like. And also, if I really want to optimize in REST for specific devices or specific websites, it's always some iterations between front end and back end developer. And that takes time, and also is sometimes error prone, because the backend developer implements something that he thinks we need, or he misunderstood us, and then we have iterations between front end and back end, and that takes time and effort. So what is GraphQL actually? GraphQL is a query language for your API, and runtime to fulfill those queries. And when we look how GraphQL actually works is we ideally would put a thin GraphQL layer on top of our business layer. And GraphQL is a great way to expose our business layer and make it work in a service way. But that's not actually how most of the GraphQL servers work in the wild, because most GraphQL servers actually are built over a set of microservices. And because GraphQL is a very good way to bring all those microservices together and have a monolithic way to actually access your data. Because just dealing with lots of microservices from a front-end perspective is quite difficult. So with GraphQL, we strive for this single source of truth, where we can explore and reason over our data by using one single endpoint. And we can fetch all the data that we need at one specific point in time in one request. And that basically gets rid of the over and under fetching problem on the client side. Basically, we get rid of the n+1 problem. And that is actually much better because we are moving the data aggregation to the backend. And because in the backend we have much better bandwidth. Think about mobile connections that might be bad. You don't have to deal with that anymore. You just have one request to your backend. You get all the data back, and the backend will actually aggregate and fetch from all these microservices or fetch from all the data sources from the database and do all the aggregation. And the server can actually do that in a much more efficient way. And GraphQL is built on that strong type system. And we saw that in the beginning when I explored basically the schema and could already see what types there are. And it's not only fake like with Swagger, the types really are enforced. And one important aspect here also is GraphQL is real time. That means the way you saw me typing up a query for a simple fetch is the same way then we can query the system in real time. And we will see that later in a demo. And all of this makes GraphQL very predictable to use. So what I've told you so far is that GraphQL basically gives the consumers or the clients of the API the power to exactly ask for what they need and nothing more. And this sometimes scares backend developers. I mean, for front-end developers, GraphQL basically sells itself, because you put a front-end developer in front of GraphQL or a GraphQL IDE in front of our personal GraphQL IDE, Banana Cake Pop, and they start crying because they can just create the requests they need, can explore the data, and they are not anymore in a position where they have to wait for the backend developers. But a backend developer has some kind of a fear of control loss. So when we see companies introducing GraphQL, there's in the beginning often a fight between those two parties. But actually GraphQL is an opportunity for backend developers, because finally you have the utilities to describe your data in a very strict way. You can mold how a front-end developer actually accesses your data, and you're not anymore limited by those protocols like REST or SOAP in the way you have to structure your data. And you also can define like maybe the cost or the complexity of a field, so you can limit what actually can be put in one request. So it's actually an opportunity for us backend developers. So we first saw that I did a simple query. So query is basically a read operation against the GraphQL server. The GraphQL server has three kinds of operations. So we have query, read, and reads are expected in GraphQL to be side effect free. And then we have mutations. And mutations, they change data, so they produce side effects. And they compare to put, post, patch, delete in REST. And then we have events, and they are called subscriptions in or subscription in GraphQL, and they give us the power to write basically queries that are executed and sent to us when something happens on the server. Okay, let's explore these operations a bit, and that's the last demo where you don't see C#. Let's just get into it. Yeah, do a .NET run. That's actually not good. Let me just fix that. Okay. Okay, .NET. Aha. Okay. There my global JSON is wrong. Let me just fix that to the correct version that I have installed. Okay. Let's get back in. .NET run. Yeah, that's always with live demos. You have a bug occasionally. Let's run that. Okay, my server's up. And then just type in our local URL into our GraphQL ID. And just do a refetch here. Oh, no, it's not on this GraphQL. It should actually come up. Let's see. Oh, it's on a different port. Ah, okay. Sorry for that. So now our demo is back up. It's basically a Star Wars schema again. We have now all the operations here available, like we have queries, we have mutations, and we have subscription. And let's first get into queries again, because GraphQL can do much more than I showed you initially. Like let's maybe explore this characters, this field hero here, which returns a character. But this time, actually, we can see that character is actually an interface and is implemented by Droid and human. Like this is a more object-oriented API for GraphQL. Oh, so we again start writing our query, and would then type maybe hero. And basically what this field does is it gives us the hero of a specific episode. So I could ask, give me the hero for maybe Jedi Returns. I have a wrong squiggle here. And I could ask for the name. Because it's an interface, I have some fields already available that I can ask for. But if I look back at the heroes field and look at the human, for instance, then I can see that there are specific fields for human, like the human has a field home planet. And the droid, for instance, has a primary function. So how would I fetch data for this specific fields? So GraphQL has a concept of fragments. So I have, for instance, an inline fragment where I can say, okay, if this type that is returned here is actually a droid, then give me its primary function. And if the type is actually a human, return me the home planet. So let me fetch that again. Because it's R2D2, I get the primary function. And if I go to different episodes, for instance, Empire Strikes Back, I now get Luke Skywalker. And GraphQL actually can do much more. There are like proper fragment definition where you can build reusable components, but I won't get into that in this talk. Okay, that's basically a nice query that I could write. Let's call it get hero, and let's see what mutations are about. So mutations, I start with basically mutation, and in this case, I write the mutation that's called create review, and I could then say I want to write a review for the episode Empire Strikes Back, and I can provide the review here as an object. In this case, I can maybe do a commentary, hello, or good movie, and I can give it some stars. For instance, let's give it 5 stars. And the important thing with GraphQL, just this top field is actually the mutation. That is what changes the data. Everything that comes beneath that field is actually we are now able to query the changed state of the server. While for this demo, it's kind of not so awesome because I'm just basically requerying what I wrote to the server. But think about when I connect objects or stuff like that, then I could refetch the changed data structures and basically directly by updating my data already update my client with that. Okay, so if I execute that mutation, I get back what I expected. I basically write something to my server and I get that back. But here's where it becomes super awesome. Let's have a look at subscriptions. For this, I open a new tab. And you maybe guessed it, for subscriptions, I start with subscriptions. And I now have a subscription that is called on review. And I basically can tell it, okay, if there is a review for Empire Strikes Back, please give me the stars. I want the stars count because I'm writing maybe a microservice that aggregates the stars count and does some fancy stuff with it. So I could play that, and actually nothing happens because there's nothing happening on my server. But I could close that. I could go to my tab where I wrote the review, and actually maybe let's first write something for Jedi. Execute that. And actually nothing happens here because I'm not writing something for Empire Strikes Back. But the moment I write a review for Empire Strikes Back, oh, that is not good. Oh, I executed the wrong. I actually executed my query. The moment I execute a review for Empire Strikes Back, the result is already here. And I could maybe just change this a bit, like put a 3 in, execute it again. And I already can see I have my changed result here. So I basically just write a simple query and indicate that it's actually a subscriptions. And then my query is every time sent to me when something changes on the server regarding this event I'm hooked onto. And this is really super powerful. And it's actually how in Facebook, for instance, the like count works. Okay, so let's get rid of that and get back to our slides because I have much more. Okay, so far we just talked about what GraphQL is. Let's have a look at what GraphQL is not. I said initially, GraphQL is not a graph database query language, and I hope everybody agrees now. And GraphQL is also not bound to a specific data source. So it doesn't matter if you have SQL Server behind it, if you have REST services behind it, if you have SOAP behind it. GraphQL is basically a layer over that and has a concept of resolvers. We will have a look at that in a minute. To resolve data for the various types it exposes. And it's also not Facebook's version of OData. GraphQL is much clearer structured and has a much richer set of features and was developed with a completely different mindset. So where OData is maybe an abstraction over a data source like MS SQL Server or something like this, GraphQL is really built for APIs. GraphQL is not a good solution for binary streams. While Netflix actually uses GraphQL, they are not using it to stream your movies. So GraphQL is very good for data, for structured data where you can drill into relations and stuff like that. And GraphQL is actually not limited to HTTP. And actually our framework is working on gRPC integration so that you can put GraphQL over gRPC. And it's also not limited to the JavaScript world. We .NET developers sometimes think that is a JavaScript thing, but actually the first GraphQL server was written by Facebook in PHP, and it actually was not written for a web page, it was written for native mobile applications. Okay, so let's have a look how GraphQL works in .NET. How can we build a .NET GraphQL server? And for that, let me kill this one and start my next demo. Okay. Let's just wait for a writer to load my project. Okay, so this project is still loading. This project is actually an empty ASP.NET Core application. The one thing that is different from a standard ASP.NET Core project is that I actually have the HotChocolate ASP.NET Core package in here. And apart from that, there is nothing in there. So we talked about that GraphQL is exposing a schema. So everything in GraphQL is built around the schema. And the schema actually exposes root types. So query is a so-called root type. And in C#, we could basically write a class maybe that is called query. And then we might, then we also saw these fields. And that actually could be in C# maybe a function. Let's a method. Let's do a string hello world. And just say hello. Okay. So
Michael,
how do we make? Yes.
Can I quickly interrupt? Can you zoom in a little bit?
Yes. Sorry.
No worries. Thank you.
That's better. I hope. Okay, so let's make this GraphQL schema. In order to do that, we have to set up our schema with ASP.NET Core. So we basically add it to our dependency injection. And we can do that by saying add GraphQL. And then we have something that is called a schema builder. And the schema builder is basically helps us setting up that schema. So with the schema builder, I have a Fluent API to say schema builder new and add query type. And then I can just say add this query. And I'm basically done. I have my schema here. It's a very simple schema. Okay, so, but there's still some missing. We still need something that execute on that schema. So we need a middleware. And that we can set up by saying use GraphQL. And now our thing should actually work. Let's watch run that because we are going to change it. Starting, we can already head back to our GraphQL ID. Say localhost 5000. Okay, let's refresh that. Oh, maybe not. Yeah, some kind. I have a different port configured than I used to. So it's on the 3. Okay, and I can see I already have my schema here. I have a hello world here, and I can see I have a non-nullable string because I actually enabled a non-nullable string support, so basically nullable reference types in my project. So I can now explore my or fetch my data here by just typing in the query, fetch that, and I basically get hello world, hello back. But that's not actually awesome. So let's make it a bit more difficult. So we talked about Star Wars the whole time, and we had those characters. So how about setting up a character and do some props in here, like an ID and a name, Luke Skywalker. And then we basically say, get a character here, character. And this no longer returns hello world. It now returns us a character. Okay. Let's see if that compiles. It does. Okay, our .NET Watch run is also up again. We refetch our schema, and we can see we have a new field called character. And we can also see that the schema builder inferred also the subtypes. So I have a non-nullable character here. I have a non-nullable int on the character, that's the ID, and I have the name. And I actually can just query for it. So we go here and see that I can just fetch the data. So it's really pretty simple to build up a GraphQL API because I can use C#. But there are two ways actually to build GraphQL APIs. I can use this C#-driven kind of way to build GraphQL APIs. And I also can use a Fluent API with GraphQL. Like if you don't have access actually to the types, you have the types maybe in a different library, you don't want to mix up GraphQL and your other library, your domain objects or stuff like it, then we also have Fluent APIs to describe these types more. So let's head back to our next slide. This is basically how we get our Hello World started. Okay, awesome. We built our first .NET GraphQL server, and it worked. So let's move on. So when we show people how easily they can build GraphQL servers by just building up some types, and they see, oh, I'm quickly started with it. But then they come back after a few days, most of the times, and say, okay, I have this entity framework here. I built my DB context up over years. It has 500 types. And how do I expose it over GraphQL? And that is really one of the most asked questions. So let's explore a bit what we can do in these scenarios. And let's head back into code, because I think that we all understand that best. Okay. Okay, so for this demo, I actually am using a Microsoft demo. It's the Contoso Uni demo. They use that on their demo, on their documentation side to explain how to use actually entity framework together with ASP.NET Core. And we are going to use that same DB context for a GraphQL server. So let's explore what this project is about. This is actually a standard ASP.NET Core project again. Let me just, before we head into the same problem again, .NET Watch run, see if framework, everything is set up correctly. It kind of starts, okay. So the startups, yes, it's a standard ASP.NET Core project. I preset this up, so if I go in the startups file, I can already see that I have a DB context in here. It's a school context, basically from the Contoso Uni. We will walk through that in a minute. And I have here already a schema builder, basically that just makes a new schema that's invalid because I don't have any types, but bear with me. And then I've already set up my middleware pipeline. I have GraphQL in here, I have routing in here. So basically a standard GraphQL, basically a standard ASP.NET Core server. And then I have also here a function that I wouldn't put that in production, but that actually just initializes my DB context with some random data. Okay, so let's have a look at the DB context. That is basically a standard EF core DB context. I actually have some.
Michael, can you maybe
yes?
zoom in again?
Yeah, again.
Yeah, thank you.
It somehow resets every time I close it down, but okay. It actually exposes again some DB sets here, like students. I have enrollments. I have courses. So a standard DB context. Also, we have relations, like for instance, a student has many enrollments, and an enrollment basically connects the student to the course, and from the other side, the course has also enrollments and connects it to students. And also, my enrollment basically holds the grade of the course. If I look at the entities, they are pretty simple, using attributes here to annotate that they're auto-generated IDs and stuff. So basically what you expect. So let's see how we can make that work with GraphQL. So in GraphQL, we are starting always with a root type. So we would start again with a type that is called maybe query. And we would actually then have to have some field. So let's first start with a simple field. Maybe we have an iQueryable here, and that exposes us as students, and we just call it getStudents. And we actually need something here. We need a service to get us the DB context. So we can say service and inject me into that function, actually the school context. That's my context. And then let's naively just return the students here. Okay, that might go wrong with a big database, but let's start with that. And we can just add that here to the query type, adding the query. And let's see what our, okay, that's not good. Let's see what our server does. Okay, it's recompiled, everything is fine. We go back in here. We refetch that. It already says, okay, character is no longer there. We can see students is there. Oh, that's cool. So we at least have the schema here. We have students, it's inferred. We automatically have a schema here. And we can also see that we have enrollments here. And when I dig into enrollments, I can see, okay, there is an enum grade with all the grades that I have, A, B, C, D, E. Oh, the E is missing, but no mind. And I also have, like, I can drill into the courses and can see all the relations are automatically set up. So let's query that. Get rid of that. Let's write students. And let's fetch maybe the last name. And maybe let's fetch the enrollments. And maybe I want also the course, so let's fetch the course and get the title. Okay, that some kinds semi-good because we have the last name, but we don't have the enrollments. Okay, so let's see how we can make that work better, because just like that, the GraphQL engine just understands that this is an object, we return that, but it doesn't know how to dig into data. So let's get back to that. So we have concept of middlewares, and if you're using the pure code first version of HotChocolate, then you can use attributes. And these attributes are actually middleware. So I could annotate here that I want to use selections. And selections are actually a way to teach GraphQL about projections. And this doesn't just work with Entity Framework, it works also with MongoDB, with any driver that supports iQueryable. So my server should have recompiled. And let's just refetch that query again. And awesome. We basically now can drill into that data like we could do in C# code, but now we can do it dynamically. And if we look actually at our console, we can see that the GraphQL query is rewritten into one SQL statement that is processed by Entity Framework. So we are fetching basically the whole graph in one go. But that's still not awesome, because we would be dead if there are more data sets in there than just a few. So we have more middlewares.
Sorry to interrupt again. Can you zoom once more? Thanks.
So we can actually go in again and say use paging, so that we can page. And let me just fast forward here. We also have more middlewares. Like we could say, okay, this endpoint is actually also filterable, and actually it's also sortable. So we have use paging, use filtering, use sorting, use selections. And the order here is actually important. Oh, let's put this here. Because if we do the projections first, the data set would be cut, the fields would be removed. So we have to have that basically first. I will explain that in a bit more. So let's fetch that again, but it would say, oh, that doesn't work here anymore. There's something wrong, because actually, since I put paging in, our data structure has changed. Because now we have here field nodes, which would cover our actual object. And I now also have here like paging information, like total count. I have a page info, which page I actually fetched. Let me fetch that again. And I get my data back. And I can see now on my field here, let's get that I now have a lot of arguments here. I have a first, I have a last, I have a where, I have an order by. So let's try something out with it. So I can now on my students can say where the last name is foo, and actually where actually I want only the first item. First. Okay, and then I would get the person foo, and there's just one foo in the set, but I also would only get the first item in my set. And if I now look at my SQL, I can see that I actually also translated this into one SQL query that fetches my data. And we also have these now as parameters, so that the query can be optimized by the SQL server. Okay, so you could spend more time on that, but time is short. Let's get back to our slides, and next time I remember to make the font bigger. So with HotChocolate, you can bring in any project that uses a queryable database driver, and we actually enable you to plug them just in. We infer your schema, and we can basically rewrite your GraphQL query into one SQL query. And you can even combine that. Like you could have multiple data sources. You have some things that come from the SQL server, some things that come from other data sources, and we will arrange that and fetch the data for you from the various data sources in an optimal way. And this doesn't stop actually with iQueryable. We are working on more database support. So some of our contributors are now working on Neo4j integration, and there are other things coming. Okay, how does it work actually? We saw this middlewares, and I said middleware order is important. And that's because middlewares form a pipeline. And basically, each field in GraphQL can have its own pipeline. So we saw I was putting attributes on this field, and by that creating basically a resolver pipeline that were then able to understand what the queryable is, and it was able to apply sorting, filtering, and even to slice the data. And it's pretty easy to build your own middleware and reshape how data processing works. But let's not stop here. We have a few more minutes, so let's make it real time. And I promise you it is as simple as doing simple queries. So let's head back to the last demo for today. And I hope I actually don't forget to make it big. So again, let's go back into Writer. Okay. It's starting up. So this is again a standard GraphQL, standard ASP.NET Core server. I also prepared it with a schema, and we have here. Here I'm actually using Fluent API, for instance, to have a query type. Yes, I said I won't forget, but I forgot. Here I have again a simple query type, and I have a field sum that has a constant return value. Okay, so let's get a real-time operation type in here. So we wrote always a query type to do the simple fetching, and for this demo we'll start with a class that is called subscription. And actually in GraphQL, subscriptions can be expressed in various ways. One of them is to just have an async function or an async method that returns an async enumerable. And that is a new type that came with, I think, .NET Core 3. And let's start with something simple. Let's put a string in here, and let's call it on messages. Async. Okay. And what our type does is actually, I prepared a few messages. It will yield back some strings and then delay and yield the next string. Basically, it's a finite message stream. And to explain to the GraphQL engine that this is actually not a standard resolver, it's actually a subscribe and resolve resolver, we put this attribute on here. And then we basically go up here, say add subscription type, and put subscription on there. Okay, so let's run our demo. .NET watch run. Okay, coming up. Let's get back to our GraphQL IDE, refetch that. Okay, it has the new schema. We can already see we have our sum field here, which is a static field, and we have our message field here. And we can see that on message is actually a string, not an enumerable of string, because the enumerable, the async enumerable, is actually our event stream. And if I now write, I want to do a subscription, and do this on messages here, and subscribe to that, I have to get my hello message. Now it's world, and now it's good. Bye. So it's pretty simple to get a stream in there, because everything that you can expose as IObservable, as async enumerable, or even as an IEnumerable can be used as a subscription. But let's try to fit in the last 5 minutes it's a more complex example. Let's have a mutation where we basically have a method that writes a message to our backend. So we get a message in, and it actually is an async here, async. And just to get it started, we return the data that we actually produced. So the GraphQL server can query that. And then we need something to send the message to, because we want to have a subscription that basically exposes these messages. So somebody can subscribe to our messages that we send in. And for that, we have something that is called the topic event sender. And that is basically an abstraction for an in-memory bus. You can have also a Redis bus that uses the same abstraction, but I'm in this example use in-memory queue. So now we can basically take that event sender and say, okay, I have something, a payload to send to you, and that is for a topic, and the topic is just called messages. You can call it anything, so you can have dynamic events. In our case, we have a static message, and we send message to it, and we await that. Okay. And on our subscriber side, we use a value task here. We now don't have a static stream like we just had now. Let's get rid of that. We now have inject also a service here, and that's called the iTopic event receiver. And the event receiver, let me break that, event receiver can now subscribe onto a topic called message. And let's get rid of the async here and basically return our payload. You like it? Yeah. And actually, it's not an async enumerable in that case. It's an event stream. And the event stream basically implements async enumerable. So let's start that. Should build, but we have forgotten one more thing. Okay, let's see why it doesn't come up. Should compile .NET run. Okay, there is still a problem with one of the services. iTopic event sender is okay, and iTopic event receiver. This should actually work with the in-memory queue. Maybe debug it the old-fashioned way. Okay, we have an exception. Multiple errors. Event stream, subscribe method. Okay, I think it's hard to debug that in 1 minute, but it actually would work this way. And we actually have these topic events receivers here, but I somehow messed something up in my setup here. So let's leave it at that. It's pretty easy to do that. And I actually would see it, I think, after the talk. But let's head back to our slides. Okay, So awesome. We built a lot of demos today and explored what GraphQL is. We actually, what you can take away here is with GraphQL, you can iterate much faster. And because you don't have to change always the backend, and the front end developer can basically drive how he wants to fetch data. And that actually allows the consumer of the API to optimize the data fetching for their use cases. And it also simplifies how we fetch data and allows the server to optimize data fetching in the backend by using things like data loader. Let me also give you a quick outlook. Our project is going full steam ahead, and we are soon releasing Strawberry Shake, which is basically a Blazor GraphQL client. It's not only for Blazor, a .NET GraphQL client that works well with Blazor. We originally thought to release it in May, but it's coming out in June. And also the tooling that you saw here, like Banana Cake Pop, which is our GraphQL IDE, is free and open source. And also we have integrations into Visual Studio, and hope to build also integrations for Rider. And we are also, and I stated that in the beginning, working on a gRPC integration for GraphQL. And if you want to dig in deeper into GraphQL, there's a good book by Marc André. He's working at GitHub and was basically one of the first people who, apart from Facebook, built a big GraphQL API. And he put all the knowledge that he acquired over the years into that book. So it's a really good book. If you want to find us, we are on chillicream.com, or you can head over to our GitHub repository. And I'm open for questions.
All right. First of all, Michael, thank you for a very, very interesting presentation showing so many things about GraphQL and HotChocolate. Thanks for that.
Yeah, you're welcome.
I think there's one question that a couple of people have been asking, and that is, how do GraphQL and OData compare, and where would you use them? Would you still use OData? Would you always go with GraphQL?
So I think they are fundamentally different. Like with GraphQL, I didn't show that you can do much more complex data. Like you can write a single query, and then you can defer parts of the query. Like where you say, okay, this data is actually more important, so that you get it directly, and then you defer other parts. And Facebook is actually doing that. If you're opening up Facebook, then you see the news stream immediately, but the comments are actually deferred. And it is built with a different mindset. OData is more, I would say, I see it as a database abstraction layer over HTTP, where GraphQL was built for APIs. So it's to expose your business layer to the world.
Makes sense. I think tacking on top of that business layer, one question that came in also a couple of times is related to, doesn't your backend code get too complex if you support all of the GraphQL freedom in querying?
No, actually not. It's actually quite simple to expose your data and to secure it. Like you could opt into very default rules. Like you could use persistent queries, for instance, where actually during development time you allow all the freedom to your devs, but as soon as you hit the publish button, you are only allowing persistent queries. That means known queries to the server. And with that, you can actually quite cheaply and make that very simple and very performant. And there are other techniques like cost complexity, where you can say, okay, and that's actually what GitHub is doing. They're allowing a cost of 1,000, for instance, let's say that. And they are giving each field a weight. Like, for instance, a field that fetches data has a higher weight than just a field that exposes a simple in-memory stuff. And then you are only allowed to fetch queries that are in a certain range of complexity. So there are tools for that.
All right, nice. Another one, slightly related, is yeah, how do you deal with API contract changes? In REST, you typically either add media queries or something like that, where you have a media type or a content type that is being returned. How do you handle changing shapes of the domain that you're exposing over GraphQL?
So was a question about versioning or media types, because that are different things, I think.
A little bit about like how do you handle fields being removed or renamed and things like that. So real schema changes.
Okay, then it's actually working more like in C#, because GraphQL has a technique to deprecate fields, and then you can introduce new fields. They don't have concept of versioning because because versioning actually always introduces a lot of complexity. And Facebook has a huge schema of over 10,000 types and 300,000 fields. And actually, they prove that this is working better at scale than with the standard versioning concept. And what they are actually doing is they deprecate fields, but they never really remove them because they don't want to basically break applications that are already deployed. Like maybe in India, there's some person that has a very old mobile device and still runs a very old version of Facebook, and that should run. So their approach to that is different than REST.
All right. I have two more questions, and then I think we'll have to wrap up. First one is about authentication and authorization. So how do you authenticate the endpoints that you have in GraphQL? And adding on to that, how do you do resource-based authorization, where, for example, some entities may not be visible to a certain user?
Okay, that are good questions. So the authorization actually is out of scope for GraphQL in the spec, so the specification doesn't bother about it. But Facebook, for instance, said the authorization should come from the business layer. So the business layer should expose basically what's possible. We on HotChocolate also integrated the authorization policies that you have in ASP.NET Core. So we allow you to do authorization. Let me just show you how that works. And go to the help here, API reference, and basically you can annotate the fields very easily. Like let's have a look. Like you basically have some kind of an authorized attribute, or in the Fluent API, if you use the Fluent API of us, you basically have an authorized extension field. Or if you're using even SDL first GraphQL syntax, you could have an authorized directive. And you basically can either use roles-based authorization on top of these fields, or you can use, and that's actually personally what I do, is using policies. And these policies are very powerful because we are exposing the GraphQL field context to the policies, and you can write very complex authorization policies that are decoupled from the actual GraphQL code, so you can test both separate from each other. So that's a powerful concept, and it's basically we are reusing Microsoft's policy-based authorization here. And there's lots to read.
Yeah. So everyone just Google HotChocolate and GraphQL and check the docs there, because apparently there's a lot of things in the framework out of the box. One more question that we have is, how did you actually come up with the name HotChocolate?
So actually, it's a bit related to my son. My brother was at Starbucks, and my son is actually was 3 years or so back then, and he was very keen on hot chocolate. So every time he woke up, he is waking everybody in the house up to get his hot chocolate. So then my brother say, let's take that as a name, because it's funnier than to call it another GraphQL.net or GraphQL or something like that, and people will remember better.
Cool.
That's the idea behind it.
All right. Yeah. Then I again want to thank you for your session just now, and then let's switch over to my screen again and yeah, wrap up the .NET Days Online.